This is part 4 of section 2.3. We want to use the factor theorem to show that the first polynomial is not a factor of the second polynomial and then give the remainder. So basically we're being asked to show that our remainder is not 0. So I want to do this division and I want to divide by a -3 into, I have a third, second, first power, and a constant, so I don't need to add any zeros. Bring down the -3. Multiply here for a +9. Add for 0. Multiply 0. Add for 5. Multiply is -15. And add to get -3. So since we did not get 0 here, it is not a factor. And our remainder is -3. Okay, now for this problem, it can sound tricky, and it really does sound tricky, but it's not nearly as bad as it sounds. We want to find the value of k for which the first polynomial is a factor of the second polynomial. So we want our remainder to be 0. What I'm going to do is I'm going to set up a synthetic division using these variables. Okay, so I'm going to put a 2, and then my coefficients are 2, k, -k, and -2. Bring down the 2. 2 times 2 is 4. K plus 4. Okay. Now multiply through here. So I have 2k plus 8. And now subtract k, so that's k plus 8. Now multiply through here, so that would be 2k plus 16. And now add, so that gives me 2k plus 14. And that is my remainder. Now, in order for it to be a factor, then this has to equal 0. So I simply make it happen. 2k plus 14 equals 0. 2k is -14. K must equal -7. And that's your answer. Okay, so now let's just start solving these things. This is another definition that sounds much worse than it is. It's called the rational zeros test. And it says that if f of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus all the way down a2 x squared plus a1 x plus a sub 0, which we often read a naught. Okay, naught is the sub 0. If it's a polynomial function, and basically this is a general polynomial here. And the notation is such that if you know your power here, then you know the variable in front, because your sub number always matches your exponent. Okay, and if this has integer coefficients, no fractions, no square roots, nice simple numbers. This does not work if you do not have integers. Then, no, if we have all of that, and P over Q is a rational number, rational means no square roots, it can be written as a fraction. So if it is a rational number in lowest terms, and it is a 0 of f, that's a lot of ifs in here, then the numerator is a factor of your constant term. So the numerator is going to be something that divides evenly into that number. The denominator is going to be a factor of your leading coefficient. So this bottom number is going to divide evenly into that coefficient. Okay? And then, so basically what this test does is it allows us to go from infinite possible answers down to, we're going to be able to create a manageable list of possible answers. Now, it's not going to give us our answer directly, but it will cut down the number of possibilities and we will be able to list all our potential solutions. We're going to have to throw some out most of the time, but we'll get a potential list. So let's just work an example here. Find the set of possible rational zeros of the given function and do not actually solve. Okay? So all we're looking for here, we're going to find our p-values, we're going to find our q-values, and then we're going to make all of the fractions. So our p-values. P is going to be everything that divides evenly into this number. Now the only numbers that divide evenly into 1 are positive and negative 1. We do need to take care of the positive and the negative version of all of these. Okay. Now there's nothing else that divides evenly into 1, so that's all my possibilities for p. My numerator is either 1 or negative 1. Now my q-values come from the 2. So I need to list everything that divides evenly into 2, which is plus or minus 1 and plus or minus 2. Now I want to go through and list every possible fraction I can. You want to sort of set up a pattern so that you're making sure you don't miss any. But my p over q values are plus or minus 1 over 1 and 1 over 2. So all of the potential rational zeros are right here. I have 4 possibilities. Negative 1, positive 1, negative 1/2, positive 1/2. So I've taken an infinite number of possibilities and simplified it down into 4, which is definitely progress. Okay. So let's find all of the rational zeros of the given function using the depressed equation to find all real zeros as needed. Okay, so make sure that you understand the difference between rational zeros and real zeros. This is going to give us things that can be written as a fraction or a decimal that ends or repeats, those are rationals, but a decimal that never ends and never repeats is irrational, but it is real. And mainly this is going to include square roots for us, okay? So let's say I want to solve f of x is equal to x cubed plus 3x squared plus 2x plus 6. First thing I want to do is to start listing all of my p over q possibilities. So my p-value is going to come from 6. So numbers that divide evenly into 6 are 1, 2, 3, and 6. And my q-values come from the coefficient of x cubed, which is 1. So this is just plus or minus 1. It's always nice when your q-values are 1 because this is also p over q. I mean, you're just dividing all of them by either 1 or negative 1, and the signs take care of it. So I have 8 possibilities here. Now, what I need to do is just start testing them. I'm going to do synthetic division until I find one that has a 0 for a remainder. In the next section, we will learn some tricks to help make your guesses a little bit better, but it really just does depend on finding a good one to start with. So it's luck. So let's just test one. So 1, 3, 2, and 6. Bring down the 1. 1 times 1 is 1. 3 plus 1 is 4. Multiply here, that is a 4, and that's a 6. And that's a positive 6, which does not equal 0. So 1 is not one of my solutions. Let's try, I don't know, negative 1. Bring down the 1. Multiply, that's a negative 1, which gives me 2. Negative 2, 0, 0, which is not a 0 there. Okay, let's try negative 2. Bring down the 1. Negative 2, that's a 1. That's a negative 2 and a 0. And again, I do not get a 0 there. Let's try negative 3. Bring down the 1. Negative 3, that's a 0. Multiply 0. Add for 2. Negative 6, and I do get a 0. So at least one of my solutions is negative 3. Now, I expect 3 solutions, but that 3 may include imaginary solutions, which we don't talk about in this section. We talk about in the next one. So this might be my only one. I might have more to come. What I'm going to do is I'm going to write down my depressed equation right here and see what I'm looking at. So as I started off with a cube, I'm starting off with a square. So this would be x squared plus 0x plus 2 equals 0. And we can solve this, except right here, we're not dealing with imaginary answers in this section. So if I were to take this, use the square root property, I would get plus or minus the square root of negative 2, which is not a real number. Which is right up here. We're asked for reals. And like I said, technically we should have 3, and here I have a plus and a minus and a negative. So that's 3 solutions, and I'm not sure why I used that color pen to close that brace, but your only solution here is negative 3. All this is saying is that if there is a rational solution, it will be somewhere on this list.